right, last unit is Unit 9 on statistics. Very basic introduction to statistics. Okay? All right. So, sets of data. Data just means a bunch of numbers you collect. Okay? Sets of data can be compared and interpreted using measures of central tendency, which is pretty much right up here, the name of this unit. Section. Measures of central tendency. That's right here, you're just moving that down. Okay, measures of central tendency. In other words, central meaning the middle of the data. Tendency, what does it tend to do? And there's different measures depending on what you're looking for. Okay, the three basic ones that we're going to introduce at first are mean, median, and mode. Yes, these should all be very familiar to you. The most famous one, the one we hear about all the time, and in fact, all three of these are averages. Every one of these is an average. But when you hear in everyday life about a batting average, or a bowling average, or a pitching average, or a goals save average, they're talking about the mean. This is the one in everyday life that we associate with the word average. Okay? Even though all three of them are mathematical averages. So to math people, they're all averages. But to the everyday person on the street, just someone you come up to and ask about the average, they're going to give you the definition of the mean. Because that's the one we use most of the time in everyday life. We talk about averages all the time. Hey, what was your average salary this year? What was your average work hours each week? How many average hours did you study? How many average hours did you practice? Average, average, average. In everyday life, they're talking about the mean. Okay? So when we talk about the mean, we total and divide by the number of items. You total them up, meaning add. You add them up, and you divide by how many there were. So if you had, 10 bowling games, you'd add up your score from all 10 games and divide by 10. That's how you find the average. If you had to remember in grade school, you had to read so many minutes per night or whatever. If you add up each night what you read and divide by 5, that was the average number of minutes or pages or whatever you read that week. You add them up and divide by the number. Now, the median, if you think about it, where's the median of the road? It's in the middle. So you're driving down a road that has like the plants in the middle or something like that. That's the median. All right? That median is the middle. Now, very important point though. Data must be in order. That's huge. You can't just look at a bunch of numbers and go, oh, there's the middle one. No, they have to be in order first. And mode, yeah, mode, most, kind of almost sounds the same. It's the one that most often occurs. It's the clear leader. Okay, so if you look at these numbers, first off, they're in order. I would highly suggest anytime you get a set of data, immediately put them in order. Always put them in order first, before you do anything. You don't need them in order for the mean, but it helps with the mode, and it has to be for the median. So you might as well put them in order. Now, if you add these numbers up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you're going to get 56.64. All right? The mode. Well, let's see. There's 3 54s, there's 2 57s, 2 58s, and 2 60s. Well, 54 has one more than anything else. So the mode is 54. And the median, you just work your way to the middle. So 54, 60, 54, 60, 54, 58, 55, 58, 56, 57, there it is. It's the middle number. Now, if I have two numbers in the middle, then I average them. I add them together and divide by 2. Now the range is 54 to 60. Or you can just say 6. You can give the size or the parameters. I personally think 54 to 60 is a better answer. I've seen textbooks teach it both ways. But think about it. If I said, I'm going to take the class on a field trip this weekend, you need to pack clothes to be prepared for a 20-degree difference in weather. Go. Do you know how to pack? Do you know what to pack? Why not? I told you, 20-degree difference. Yep. You don't know if that's 80 to 60, 80 to 100, negative 10 to negative 30. You just know the size of the difference, right? But if I tell you, hey, for your field trip this weekend, pack for 60 to 80 degree weather. Do you know how to pack? Yeah, it gives you more information, doesn't it? So even though some textbooks say that is the range, and it mathematically is, it's the size of it, I think you get a lot more information writing it this way. I will accept either, but it gives you more information. Okay, so which of these is the best to use? The mean. There are no outliers. I'm getting ready to say that. Extreme data. Okay, so think about it. If, these were speeds that someone was clocked at going down the highway. Well, the speed limit is 60. Between 54 and 60 really is not that big of a deal. So if I said the average speed was 56.64, that's pretty good. But if someone came down in a Maserati doing 135, what's that going to do to the data? It's going to really pull it up higher, right? It's an outlier. It doesn't go with the rest of the data. It's an extreme number. Or if someone's engine started blowing out and they're like puffing smoke out and they're going like 15 miles per hour down the highway, chugging along, just trying to get to the next exit, that's going to pull the data what? Down. And it's an extreme number compared to the 50s and 60s. That's what an outlier is. But if you don't have an outlier, mean is the best data. Okay, so problem here, they're not in order. Okay? So to find the mean and the mode is going to be kind of a pain. So we have to rewrite them. So we look through and find the smallest number. It's 208. I cross it off when I do that. I also try to write them underneath exactly the same space so I can keep track that I have the same matching number. Now after that, it looks like I have 218. After that, looks like 27. Now I'm going to get too big for these. I can't match the size. So the best thing to do is always count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I should have 13 when I'm done. Yeah, 13. So after 227, it looks like 234. So we have 234. And then we have 235. You guys can all do this on your own. And then it looks like we have a 236. And then we have two 250s. Oh, we have a shot at the mode. 3 250s. Oh, we got a definite shot at the mode. 250. You're going to be hard to beat that. Then we have 255. And then we have 67. And then we have 280 and 295. And I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, good. Most of the errors that happen in statistics is losing a number or writing a number extra. Now, I'll just save you the trouble. If you add all these up and divide by 13, you get 247.4. The mode, we got it, is 250. Now we're going to go from the beginning and the end. Now, if you don't want to cross out, you can always underline. 208, 295, 218, 280, 227, 267, 234, 255, 235, 250, 236, 250. What's in the middle? 250. Okay? Now the range, again, I think the better range is to put 208 to 295. But if you put 87, I would accept it. Okay, so this one, you know, you do have 208 and 218 down there. So, you know, you could say median would be a little bit better. You could call 218 kind of an outlier. It's pretty low down there compared to the, you know, away from the rest. Just slightly. If you said mean, see the thing about statistics is, if you can argue your point, you can justify it. So if you put mean on a test and justified it, you know, that's fine. As long as you argue your point. Okay, with this set of data, okay, we're just answering one question. Which would be the best one? Well, you don't have to put these in order. You can clearly see there's something fishy about this one, isn't there? 34. So we're going to say median again. 34 is an outlier. It's pulling the data down. Okay, so let's look at this. Data sets. Look at these numbers right here. Any numbers pop out at you as an outlier?
67.
Yep. 67. Okay, on the next set. Is there an outlier there?
12.
Yeah, I would say 12. That's pretty far away. And the next one. Yeah, 391 is pretty far away. Okay? Now, I'm going to give you these numbers so you can see what happens. So the mean on this one is 24.56. If we take that outlier out, it's 19.25. So like you predicted before, the 67 pulls the average up. The average here is 34.13, the mean, and 37.29 without it. Why? The 12 pulled it down. And for this one, it's 300.86. And what do you think that means? It's going to be higher or lower? It's going to be lower, 285.83, because the 391 pulled the average up. Now, we already talked about what mean, median, and mode are. This is just some data for you to know. Okay? So the mean is often used and popular in business, engineering, computer science, also sports. Not up there, but like, you know, sports science stuff. It is unique. There's only one answer. Okay? There's only one average. You add them up and divide. Disadvantages, they are affected by outliers. We use averages in school all the time, right? But there's every once in a while there's that test where everybody does well on it, but a couple kids bomb it, or everybody bombs it and a couple kids ace it. Okay? Averages are affected by that. The median, what are the advantages? Well, extreme values like outliers don't affect the median because median just has to do with place value. So it doesn't matter in this place right here if I'm a 7 or a 75. I'm just a place. And so when you're counting places from the outside to the inside, they're just numbers. So it doesn't matter what that number is. So the value doesn't matter. So outliers don't affect median. And there's also one answer. Disadvantages, it just loses in the popularity contest to mean. It just, no, not a school, I guess. And then mode. Extreme values also do not affect the mode. All right. Disadvantage. Look at all the disadvantages. It's not as popular, like this high school, or worry about popularity. But it's not necessarily unique. There can be more than one answer. You can have one mode, two modes, three modes. Okay? There can be a tie. When no values repeat, then there's no mode, and then it's useless. So if I take the numbers 1, 3, 13, 52, 75, 108, there's no mode. So what good does that do? And then if it's more difficult when there's one mode, it's difficult to interpret and or compare when there's more than one mode. So if you have two modes or three modes or four modes, it's like it doesn't really help much. So mode is the least often used. How do I know which measure is best to use? Okay, so the price of a home in a certain area. Most go with median, and the reason is you could have that one home that really brings down the value. Or have you ever been on a block where like somebody tears down the house and puts up like this mansion, and it's like that place is way more expensive than every other house in the block? Okay, that happens at times. So median is more often used there. Average goals in a soccer game? Yeah, mean. We're going to use that. That's often used in sports. Age of a 7th grader? Mean. There's not really going to be outliers there. Everybody's going to be around the same age, 11, 12, 13, something like that. And average age of the class is 13. Again, that's pretty much the same as the previous one. Mean. So that's what we would use. Okay, the range is not a measure of central tendency. We talked about the beginning, three measure or mean, median, mode. Range is not, but it does tell you the data spread. Okay, so the range of the data here. Here's our lowest. Here's our highest. It's 54 to 60, or just 6. That's the spread. This one, 208 to, what was the highest one? 295. So 208 to 295. If you subtract, you get 87. So these numbers are the spread. Okay, how big is it? Again, you can use the range either way. I just prefer actually writing it as a range. It tells you more information. See, you can get the size from the range like this, but you can't guess the range from the size. So for that example I gave you again, when I said 20-degree weather change, it could be 80 to 100, 60 to 80, 50 to 70, whatever. We don't know. Okay, so work out the mean and median for these data sets and decide which is the more reliable measure. So I'm just going to give you these numbers. Again, mean, I would add them up and divide by how many there are. 2.78, 19.25, 34.1, 106.43, and 288.57. Those are the means. If I add each of these up and divide by how many there are, that's what I will get. That's how you calculate the mean. What? What's the last one? 288.57.
What's the last number of this second? Is that a 5?
288.57. That's 19.25.
Okay.
Now the median is just the middle number. Now these are all in place, so I can just work my way to the middle. You can tell what the median of the first one is going to be because it's almost all 5s. Okay? Now the median for this next one, we talked about this but haven't had it yet. Look, 10, 25, 15, 24, 15, 24. Oh, there is no middle number. So what we do is add 22 plus 19, which is an odd number. So when we divide by 2, we actually get 20.5. The middle number here is actually 37. Again, there's 3 here, 3 here. We would add and divide, but since they're the same number, it makes no difference. The next one, the middle number is right here, 101. And for this one, there's 3 here, 3 here. The middle number is actually 279, So there's only one of these, or two, I'm sorry, my bad. Well, sort of. One of these where we had to add and divide by 2. This one you didn't have to because they were the same number. Now, the best measure is the one that is going to be closest together. So mean is going to be if they're closer together. Mean is going to be closest together. So this one, pretty close to each other, right? One difference, less than one difference. The rest of them have, this is too big of a difference. That's median. This is 3 away, median. That's 5 away, so this is going to be median. And this one is a lot more too. So if they're close together, mean would be very good. If they're kind of further apart, median is going to be your best option. Okay, so mean and range for Chris and Anna. Okay, discuss which of these conclusions are correct. So it says Chris is more reliable. Anna is the best because her mean is lower. Okay, what does it talk about? Here's a summary of Chris and Anna's score out of 10 in gymnastics. We obviously want a higher score. Okay, so Anna is the best because her mean is lower. That doesn't make sense at all. Because you want a higher score. Anna is better because her range is higher. Well, if her range is higher, that means she has some really good scores and some really bad scores, right? If she has a bigger range, you don't want really bad scores. So that doesn't make sense. Chris must have gotten a higher best score. And on average, Chris is better and more consistent. Okay? So, we have 3 let's think about it. Chris is more reliable. Well, it doesn't really give any reason why. It just says he's more reliable. That doesn't work. You got data to back it up. He got a higher best score. Don't know that. So our answer is this one. Now, why is that? Well, he has a higher average than her, that's for sure. And since he has a smaller range, that means his scores were closer together. So between the two, he has a better overall score usually. Okay? Obviously his mean is better, but since his range is smaller, that means his scores are tighter together. He's more consistent as opposed to having a bigger range. Now, here are their actual individual scores. Okay? This is Chris, and this is Anna. Okay? So if you look at it, Chris, he had, some 5s, all 6, and then 7s and 8s. But Anna, she had a 3 and a 4, so much larger range. So that sounds good.